This video is about cells and pH. So we'll be learning about what the pH scale is and why is it important. So one of the most important substances that is dissolved in water is actually hydrogen ions, which is fundamentally a proton. So if you think about a water molecule, it's hydrogen, it's two hydrogens and one oxygen, H2O. At any point in time, about 1 in a million of those water molecules will just spontaneously break apart. And when it breaks apart, two hydrogen ions are released from the one oxygen, or more likely, one hydrogen is released to form an H plus, and then you have a hydroxide ion, which is an OH minus ion. Too much hydrogen ions in the water, remember these are fundamentally protons, they can have a tremendous impact on cells. So basically, what they can do is they cause cells to change their molecular shape, which can damage or disrupt systems and potentially even lead to death, cell death at that point. As one of the most abundant resources on Earth, obviously, water is everywhere. And so the potential of hydrogen ions in water to be acidic can cause great changes at small scale and at larger scales. So pure water contains an equal number of hydrogen ions and OH minus or hydroxide ions. So it's neutral. So pure water, it's mostly going to be H2O. Again, a hydrogen ion may split off of an OH group. So if that hydrogen ion is still balanced, because you still have a positive charge and a negative charge. However, some solutions, when they're dissolved in water, can cause the solution to become acidic. So remember, water itself tends to be neutral because for every hydrogen that's broken off, OH minus will balance it out. So one positive and one negative is neutral. However, imagine that I dissolve hydrochloric acid into water. So hydrochloric acid is a hydrogen bonded to a chlorine molecule. So when it's dissolved in water, and again, we have a positive and a negative, so it's an ionic substance and it tends to break apart and dissolve in water. Remember, ionic substances dissolve in water pretty easily. So the hydrogens break off, but they're not breaking off an OH. So for every one plus charge, there's not an OH minus charge to balance it out. Instead, you have a chlorine, and then you have these hydrogen ions that are adding. So you're increasing the number of hydrogen ions in the water. So you're increasing the acidity of this solution. A base would be a chemical that adds hydroxide ions to a solution. So that would be something like sodium hydroxide, Na, and then OH. This, again, it's an ionic compound, so the sodium can break off, and then we're increasing the number of OH minus substances that are in there. So when they're combined, if I have an acid and a base and I combine them together, I can neutralize the substance. So if I have too many hydrogen ions, I can add a substance that contains OH minus or hydroxide. I want to say OH minus, talking about hydroxide. So hydrogen ions in an acid, something is acidic. I start adding a base which contains hydroxide ions, and that will neutralize the substance. Now, it's not that simple. You have to be careful. If you add a strong acid and a strong base together, you get all kinds of volatile reactions. It's not something you want to do. However, there are ways to actually use bases to neutralize acids safely. So before we get into more about the pH scale, let's talk a little bit about why acids and bases are important to life as we know it. So first of all, acid rain, some pollutants combine in the atmosphere. So remember, we have a lot of water in the atmosphere. Some pollutants can combine with water vapor and increase the amount of hydrogen ions that are in that water droplet. So when it returns to Earth, it is actually acidic. Acid precipitation can kill vegetation. It can destroy artifacts like statues that contain a lot of limestone, for example. It will dissolve away that limestone pretty easily, so damaging to buildings and things like that. Acids are sour, and sometimes in their scenario, they actually add a tart flavor. So when we say sour, we think about something like lemon. Yes, lemon's definitely acidic, but when you're talking about something like yogurt or sour cream, those are sort of sour-ish, not terribly, but that's because they do have those hydrogen ions in them. So acidic substances give that sour flavor. And again, something that is extremely sour like lemon. Strong acids help you digest food. So your stomach actually produces acid. You may have to take an antacid because if you have too much acid in your stomach, it can come back up as reflux and cause that heartburn feeling that some people get. So that's an important role for acids in our bodies digesting food. And then immediately when your food leaves the stomach, it hits the duodenum, which is the first section of your small intestine, and it is buffered. And we're going to talk about buffers in this video as well. So buffers actually kind of also help to neutralize acids and bases. And finally, household cleaners, they tend to be basic. And so they can actually, so a base, if you think about a super strong base, it can actually burn your skin just like an acid could if it's extremely strong. But some of the less strong bases, which would be like a lot of cleaning agents and soaps and things like that, they can actually break up grease without corroding metal or other substances. So you could probably wash a lot of types of glass with acid and not really cause any problems, but a base you can use on many different types of materials without it corroding the surface. Because if you put an acid on metal, it's going to tend to corrode it. So let's look at the actual pH scale. So pH stands for the potential of hydrogen, and it's defined as the logarithm of the hydrogen ion concentration. So it's a log base 10 scale. So what that means is that with each unit on the pH scale that we move, that represents a 10-fold change in hydrogen ion concentration. So if we start neutral in the middle here at 7, which would be pure water, if we go from a pH of 7 to a pH of 8, it's not that it increased 1 pH, it increased 10 times as much. So something with a pH of 8 is 10 times more basic than something with a pH of 7. And notice that on acids and bases, anything that has a value lower than 7, which is 7 is neutral, anything lower is going to be an acid, anything higher is going to be a base. So if we go from 7 to 8 to 9, we've gone from 7 to 8 is 10 times. Well, from 7 to 9 is 10 times 10. So that's 100 times more basic. So you're seeing what that difference in the hydrogen ion concentration or the hydroxide ion concentration is when we're looking at the pH scale. So the pH scale can be used to tell you whether something is acidic, neutral, or basic. So we have pH test strips. Some of you might have used those with swimming pools. You might have used them in a science class. You just dip it in the solution and it comes back, and the color will indicate how acidic or basic something is. So we can see on this scale things like hydrochloric acid I mentioned earlier, it's extremely acidic. And then we have things that are less acidic. So you get around to blood and mineral water, wine and cola. Those are still things you can consume. Well, probably shouldn't be consuming blood unless you're a vampire, but mineral water, wine, cola, those are slightly acidic and you can fairly safely consume those. Although if you drink too much cola, as you know, it can actually cause some enamel erosion on your teeth. Back on the basic side, we're seeing things like our laundry detergent and our soap, and I talked about those being cleaners. But then you get all the way down to sodium hydroxide, which is lye, and it can actually burn your skin. And there's terrible stories of people across history who use lye to dissolve their murder victims. That's something for another day. Let's look at buffers. So we're talking about how acidic or basic something is. Buffers actually help to regulate pH, and in the bodies of living organisms, buffers regulate pH of body fluids. So an example of where this occurs is with red blood cells. So if your blood becomes too acidic, which is acidosis, the opposite is alkalosis, but if the opposite would be your blood being too basic. So your blood has a sort of a zone of normal pH. So if the acid starts to get too high in your bloodstream, obviously that's going to cause problems for the body. So blood cells actually produce buffers that remove hydrogen ions from the body. So an example of how this could happen, your muscles produce hydrogen ions like during extreme exercise. So if you are engaging in like let's say that you're sprinting or something like that, your body's going to produce hydrogen ions as a result of chemical reactions that are happening. So the equilibrium is going to shift to the right. You see an equation down there. The bicarbonate is the H2CO3 that's there in the middle. So in the process of like exercising, it'll shift to the right. You see that carbon dioxide and water being produced, and then hydrogen ions are actually bound in the oxygen. And I said exercise, so no, this is, I should have said shift to the left. So it shifts back to the right when your body is taking hydrogen ions out. What's actually happening is it shifts to the left. The hydrogen concentration is increased on the left side of the equation. So in extreme exercise, you're kind of moving in that direction. So then the blood starts taking up those hydrogen ions and you move back to the right, which is a more normal. Really, that central is where you want to be, but you start moving back towards the right to get back to that normal and that central. So buffers, blood, like all buffers, is kind of limited in terms of its buffering capacity. So this means that your blood can only take up so much hydrogen ions, and eventually it kind of gets to that point that it's taken up all it can, and that's what limits performance. So if you're sprinting, for example, and you keep producing hydrogen ions, the blood's going to get to the point it can't take up anymore. So you're either going to have to slow down or you're going to have to stop. Um, and so that's kind of how a lot of buffers work. And I mentioned the buffers that take up hydrogen ions as food is leaving your stomach. Same thing. It's removing those hydrogen ions so that your intestines don't become eroded by the acid. Your stomach has the capability of existing in an acidic environment, but your intestines not so much, and so it needs to be taken up. So that's kind of how buffers work.